One.
She'll tell you when
It's ready.
Yeah.
Well, good afternoon, everybody, and good morning, Jordan, out on the West Coast. I realize it's a bit early for you to be up, but we'll get to your experiment in a little bit. Before we start on today's program, though, I want to mention once again an astronomical event that's starting or going to happen next Sunday, Monday, Tuesday, the 11th through the 13th. Write it down. Doesn't happen very often. If the sky's clear, you want to be out there roughly 9 o'clock in the evening in the twilight to 9:30, but not much later because it will have set and then you won't be able to see it unless you're with Jordan, who's on the West Coast and it's not dark yet at 9 o'clock our time. Is it, Jordan? You awake? What's happening?
No, it's not dark at that time.
No, but you'll be able to see it when it does get dark. You're up at midnight, so around midnight, 12:30 in the morning, you'll be able to see it. Maybe Megan will drive you out to the mountains again and you'll be able to see it really well. So where do you look? To the west, where the sun has gone down, and you don't have to wait till next Sunday night. You can kind of, whenever it clears up here in the east, I'll go out at dusk and looking to the west, you'll spot the brightest, quote, star, which is not a star. It's the planet Venus. At this point, it's our evening star, and it's hanging there, a beautiful jewel, very bright in the darkening sky. Quite close. And once again, I'm sorry, guys, I forget if it's a handspan away, is a much fainter, more reddish Mars. Two planets, Venus being closer to the sun than we are, Mars being the next one out. Oh, by the way, a diversion. On the radio last week, the Chinese, you may know, have landed on the moon. And they've put this little rover. Oh, wait a minute. Yeah, I think real people landed on the moon, real Chinese people. And they had this rover out and about. And just like we heard the wind blowing on Mars 2 months or so ago from our spacecraft, you could hear the following, which was the noise of this little rover moving across the surface of Mars, which once again, I thought was pretty amazing, right? Yeah. Okay, back to our conjunction. Quiz time. Remember we had a conjunction in the wintertime between Jupiter and Saturn? So what's a conjunction? And Mary Lou, since your picture is the biggest and the brightest on my screen, I'm going to pick on you for an answer. What's a conjunction?
It's when two objects move together and pass each other.
Okay. Apparently move together.
Okay.
Right. One of the things that Melanie is going to do between now and the next couple of days is where really in space are Venus and Mars? Because they're obviously not going to run into each other. That's not possible.
Right.
But apparently they are, because on Tuesday, okay, starting off on the 11th, they're going to be pretty close together, maybe a few fingers apart or not even that many. And off to the right of them, the pair, is a beautiful, very skinny new moon crescent. So that'll help you along with the brightness of Venus to find them. And then each night, Venus and Mars will come closer, apparently, and closer together. And on the third night, the 13th, with your naked eye, it'll look like they're right on top of each other, literally merge. Meanwhile, the moon, being closer to us, moves faster, apparently, in the sky. So on the second night, it'll be off to the left of this pair. And then the following night, the night of the conjunction, it'll be either even further to the east, to the left. So if we ever get clear skies, I think this once again is, who knows, I forget, you could look it up and Google it when it's going to happen again, but things like this don't happen that often. So, and Melanie will let you know where they really are, you know, because this is a visual game, right? We're sitting on the earth and we're moving around the sun. Well, so are they. One in an inner circle, one in an outer circle. And every now and again, things line up. So I want to know, where are they? So I drew, can they see this if I do what?
Mhm.
That's really terrible. You guys can do it too, and you can look it up online. Maybe Melanie will suggest an app to find it, but you can draw the sun in the middle and then the various orbits, and then find out, probably NASA will tell you
Mhm.
where we and they are. What would be the app that most likely can find it?
I don't know yet, but I have on our events page, I have a event for the conjunction, so I'll list whatever I find on that event page.
Okay. All right, to move on to assignment time, homework time. And I reminded Melanie here of, she was to look up the date of the summer solstice, because that's basically what we're talking about this week. The solstice in the summer, the tilt of the earth, and our seasons. So when was the solstice this year? She's cheating. I'm pointing to the answer.
June 20th.
Right. This year it was the 20th of June. But I was curious. You remember back when we were talking about Easter and Passover? The dates vary. It's not always the 20th of June. So she just looked it up on various sources.
Yeah.
And they said it could be as early as the 20th or as late as the 21st.
Or the 22nd.
22nd,
Yep.
22nd. Oh, well, let me write that down. Say again, the 20th to the 22nd?
The 20th to the 22nd. Yep.
Now, I have a vague memory that it was on the 19th once, and that's what we were trying to find, if that was, because you
Mhm.
can't always trust all the answers on the computer. It depends on who puts them in and how knowledgeable they are. So Sandy's sitting over here, I see peripherally. She's looking up to see if there was ever a summer solstice on the 19th of June. Now, Rima had an assignment, but poor Rima is stuck in the library over there to the left of us, taking care of library business. But she was to look up what happens if you get up every morning at dawn and look to the east throughout the year. Where does the sun come up? Now, does anybody out there that's listening, Deb, Mary Lou, Jordan, I do have the answer. We worked it out earlier when I came in. What happens to the movement of the sun along the eastern horizon? Anybody want to jump in?
Well, I think on the vernal and the autumnal equinox, it's due east.
That's
then-
correct. Everywhere in the world. Exactly
And then it
east.
travels to the south for the summertime and then back to the east for the autumn. And the
Wait.
same thing for the winter, I think.
Well, if you were in the southern hemisphere, that may be true, but in the northern hemisphere, Mary Lou, what happens is, let's start with March, springtime.
Yeah.
Then every morning it inches further to the left, further north of due east until June 20th, the summer solstice.
Okay.
And then the sun rises 23.5 degrees north of due east. Why
Okay.
23.5 degrees, a magic number for the earth?
That's the tilt.
Okay, want to say it?
Oh.
Can they hear?
That's the tilt of the axis.
Right, the north-south pole. Think of a top spinning on your table top. We do not sit upright. We have a tilt, 23.5 degrees. And so as the sun moves along the horizon, it's reflecting that. And so 23.5 degrees further to the north, and you can check it out. Well, it's not going to be clear tonight, probably. The first clear night or morning, go check it out, maybe Saturday. And then it swings back. And in September, once again, it's due east. And then it creeps further and further to the south, another 23.5 degrees to its southernmost point. Does this remind you of the Saros cycle for the moon? Okay. So the difference between the summer solstice, I'm going to turn, let's see. I'm going to turn my back to you, but this way is east. So east. Let me think. In the summertime, it rises over here, in the wintertime over there. And if you add 23 and a half, what do you get, Sandy? Add 23 and 23.
23 and 23 is 46.
46 and another half and a half.
47.
47 degrees. So think of your arms straight up and straight out. That's 90 degrees. So 45 degrees or so is about half that distance. So that's the difference between how the sun moves throughout the year. All righty. Maybe, well, we can't. Debbie, did you look up when the spring equinox, what constellation in the zodiac it was 6,000 years ago? Oops, Debbie, is she there? Oh, we'll come back to Debbie and Piper.
Oh,
And
she unmuted.
Not
Hmm?
mute. I was muted.
hi, Debbie, do you hear me?
I heard you. I tried to look it up.
Yeah,
I think is the sun in the Aries right now.
yes,
So was it in Taurus?
yes, I think it was. And this is very complicated. And so we won't get into it this time. Maybe sometime in the winter when we have enough extra time. We're not pressed for a lot of details per subject. We can go over the zodiac, the 12 constellations, and how the sun moves through them once a year, and what that means to astrology, which we really don't cover in this scientifically based astronomy class, but we can touch on it. But I think what was important in Taurus is that if you look at a lot of ancient monuments and religious symbols, Taurus as a constellation, which for us is in the winter skies, between the Pleiades and Orion, that's where the sun was in the springtime. And 6,000 years ago, many cultures, not all, but many, had turned to agriculture, abandoned the hunting gathering lifestyle. And so all of a sudden, a calendar, not based on the moon, but on the annual cycle of the sun became important. And the signs of the zodiac became important symbolically and religiously and philosophically. And so if back in the early days, it was Taurus the bull, you can see why then a bull became an important idol and symbol for ancient cultures. Alrighty. Oh, Mary Lou, I think I had another question for you. I said, what if the Earth did not tilt, but simply stood upright on its axis and rotated around and around and around with no tilt? What would happen to our seasons?
Okay. We would only have one season, which would correspond to spring or autumn. There would
Okay.
be a, you want me to read all of this? Because I thought
Yeah,
it was
why
interesting.
don't you just put it in your own words if you could, or whatever you prefer?
Well, due to the Earth's elliptical orbit, the whole planet would experience a mini summer in January and a mini winter in July. And the Earth is the furthest when that part of the Earth is furthest from the
Well,
sun.
we'll get to that in a bit, because once
Okay.
again, that's kind of complicated. Okay, I want everybody to picture this. You can take a pencil. That's the axis. And the top of the pencil pointing towards the ceiling is the North Star, the North Pole, and this thing sitting on the table is the South Pole. Now, if you just rotate that pen in your hand, and Sandy, haha, you hold the flashlight. Well, okay, you brought your big flashlight. That's the sun. But hold it right there.
Okay.
That would mean the sun would always shine pretty much on the equator, which means the equator would always be hot. Up here at the poles, the sun's not going to shine much at all. It's always going to be cold. And everywhere in between is a gradation of that. So whatever latitude you lived on, there would be no seasons. Whatever it was, it would be all year long. Okay, so, all right. So we'd have, in a sense, no seasons. It'd just be the same year round. Okay, Jordan, are you awake enough to show us your Uranus experiment?
Yeah.
Okay, and did you manage to open up his?
I did not.
Okay,
I sent you an email, Jordan. I wasn't able to open those files.
Okay.
Am I able to,
hang on a sec. We'll see if we can.
Is it because they're through the drive?
yeah, I even tried to save them to my Google Drive. And it said that it didn't recognize the file type.
I can send the normal photo really quick. That might work. I used them in Drive because I couldn't rename them on my phone.
Okay, let's try that.
Okay.
Okay, while the two of these technicians are working out the ins and outs of the magic box, I'm going to, is it okay, Jordan, if I explain what you did?
Yeah.
Okay. I had asked Jordan and some of his crew there on the West Coast to do the following. It turns out that unlike us and most of the planets in the solar system, Uranus has had a very weird history. We're assuming that somewhere way back in the day, early on, something very big whacked into Uranus and knocked it over sideways. So its tip is 88 degrees, which means it's practically lying on its side. And so instead of revolving around the sun on its orbit, like most of us, it's lying on its side and rolling along its equator, which really, as far as we're concerned, screws up the day and the night and the seasons. So what I had Jordan and his family there do was take a table and cover it with white cloth, and then have some sort of low source of a light that would shine in all directions, sit in the middle of the table for the sun. Then I had two of them take a pencil, one of their fingers, and a string. The finger would go in the middle where the sun was, and then the pencil at the end of a taut string would go around in a circle. Now that was inaccurate because the orbit is not a circle, rather it's an ellipse, but for us, the circle is good enough. It's close enough. Then they were to get, I had said a tennis ball or an orange, and somehow stick like a pickup stick, something skinny, through the orange, right smack through the middle of the tennis ball to make an axis. And then to paint a line where the equator would be. And then put the sunlight in the middle, take the ball, Uranus, put it on its equator, its side, and roll it around the orbital circle, stopping 4 times, equally apart. And then Megan or somebody from up above was to take a picture so we could see how the light of the quote sun shone on this weird, I'm calling it weird. It's like the British driving on the wrong side of the road, right? Okay. My son-in-law is not listening, so I can say that. And stop 4 times and see what's happening with the sunlight. Okay, Jordan, were you successful in the experiment? And if we can't get it, technically, you can tell us what we would have seen.
I think so. I just resent the pictures.
Okay.
Those should work, but they're
It
not
should
titled,
work.
so I have to figure out which one's which.
Okay. Did you happen to look up now? First of all, how many Earth years do you happen to know that it takes Uranus to go around the sun?
It takes 84.
84 years. So in our lifetime, if we live to be 84 years, wherever Uranus was in the sky, and you, let me think, you can't see it, nor you have to have really good eyes and be in a desert country to see it without a telescope. after 84 years, it'd be back in the same place in the sky. So it's not like Mars or Mercury or even Venus, who kind of zips around in a year or two or whatever. It takes 84 years to go around. Do you happen to know what the length of its day? Ours is 24 hours. What is it on Uranus? Do you know?
Hold on, I can check. I knew what it was, but I haven't looked at it.
Okay, well, I've got it down. So it takes 16 hours. So there's 8 hours of sunlight in when it's that way, and 8 hours of darkness. Okay. How are we doing on the picture, Melanie?
Hasn't come
The
through yet.
email.
Hasn't
it's
come through
coming.
yet.
No.
Okay. We'll pause then but we'll come back to this picture, Jordan, of what you saw in a few minutes, but we'll move on because we're going to run out of time otherwise.
Okay, I sent them as a reply, so they might not come as a separate email.
Okay.
All righty. Now, Jordan, I don't know if you did this. I forgot to remind you, and it was it was 2 months ago, I think, when I asked you, did you look up the number, how in San Diego on June 20th? You'd have to look it up either in the newspaper or on Google. How many hours of sunlight did you have from sunrise to sunset in San Diego?
I'm not sure.
Okay, I have it rounded off. And we can look that up later, everybody, if you want to. For us in New York State, and my daughter Kathy, who also lives down in San Diego, whenever she visits in the summer, she says, "Oh, I forget what it was like to live up north. In the summer, it doesn't get dark till so late." Well, of course, when my friend John and I went to Alaska in August, it didn't get dark till midnight. Jordan, do you want to jump in here and tell of your experience 3 years ago in Alaska? And it happened to be on the summer solstice that we were there that week when you
It was
took your
light
walk in
almost
the
the
park.
entire time.
Pardon?
I think it was light almost the entire time.
Tell them about your walk in the park that first or second night we were there.
I just remember it being like pretty much like day most of the time.
Okay, yeah, I think it was our first night, and Dave and Kathy hadn't met up with us yet, and we were in the big Marriott Hotel, one of 3 skyscrapers in Anchorage, Alaska. And it was about 9 o'clock. It had been a long day. We'd both flown in from different parts of the country. I was ready to hit the sack. Jordan, of course, wasn't. He was wide awake. He wanted to go for a walk. So off he went. 3 hours later, he comes back with blisters on his feet, and he had hiked all the way down through Anchorage, across the railroad tracks, down to Turnagain Arm, which is an estuary. Well, I'm not sure it's an estuary, but it's tidally affected. So he got there when the tide was out, and so there were a lot of mud flats and big signs. Don't walk out on the mud flats, bird sanctuary. And then he came back. So he was gone 3 hours. He probably walked 12 miles. And when he came in the door, I was still awake, of course, at midnight. The first thing he said was, "Do you remember what you said?"
No.
It's a good thing you have a grandmother to remember all these things. He said, "The sun didn't go down until midnight." So the further north you go, the longer the days become. And so for us in June, it's almost 15 hours from sunrise to sunset. But down in San Diego, it's a little under 14 hours. And I think their latitude is 32, 3, 4 degrees. So, and ours is about 41, 42. So the further to the equator you get, the more even your night and day, regardless of the time of the year. It's only as you go towards the poles that you begin to get the extreme. Let's see. All right, are you still playing with that?
Mhm.
Okay, we'll just move on.
It hasn't come.
Okay.
Can you hear me?
Yes.
This is Regina.
Oh, hi, Regina.
Hi. I learned a few years ago, closer you are to the equator, the faster the twilight it goes. You know,
Yes,
up here, there's a lot of time from sunset till it gets dark. But the
right.
closer you are to the equator, it goes really fast.
Do you know
Like the
why?
blink of an eye, it becomes dark.
Do you know why that is, Regina?
No, I don't remember.
Well, okay, think of it this way. Have you ever gone skating with a bunch of people?
Yes.
And there's somebody that's in the middle, and then you have like 10 people in a line holding hands, and you skate in a circle? Who has
Yeah,
to
and the
go
one on the outside goes faster.
faster? Because they have to cover more ground, right? So think
Yep.
of the Earth. At the equator, it's almost 24,000 miles around the equator, but the further north you go, the circle around the Earth, the latitude lines get smaller and smaller
Oh,
till you get to the
shorter,
poles.
yeah.
It's just a point. So people, you don't realize it, but if you're living on the equator, you're moving a lot faster than people here at 42 degrees north. And by the way, sometime in the winter when we have more time, or maybe in late fall or early spring, when there are not as many exciting stars to watch, we're going to talk about motion and how we're moving. Okay, so for us in the northern hemisphere, and I was going to ask Bob what happens in the southern hemisphere because he used to take sabbaticals down in Australia, down under. For us in the northern hemisphere, the longest day of the year is in June, in the summertime. You guys ready for a little bit of math? I usually try and steer away from this, but it's important. It's important. If we were to go way out into space like the astronauts and look back and take a picture of the blue marble, you really wouldn't see any lines on the Earth. However, there are some what I call real lines on the Earth that are made by the sun throughout the year. And the one line would be, pictured in your head, big beach ball, the Earth. The equator divides the northern and southern hemisphere. It goes right around the fat belly. What that means in astronomy is that twice a year, at the equinoxes in March and September, the position of the sun on the Earth is directly over the equator. So on those 2 days of the year, if you lived anywhere along the equator, such as Lima in Ecuador, I believe is a city right on the equator, then when you get up in the morning, the sun would rise directly east and go in an arc right straight up in the air over your head, 90 degrees at noon, and then set directly behind you in an arc to the west. That line, if the sun were a magic marker, and the sunshine that came 90 degrees straight down marked the Earth, you'd mark the equator. And that's why the equator is where it is, because of what the sun is doing in our sky. So let's start in March at the equinox, when the sun is straight overhead over the equator. Every day after that, the sun seems to move a little bit further north every day until June 20th, the summer solstice. That's as far north as it ever gets, which means if you live and that's the magic number, 23.5 degrees to the north on the globe. We call that the Tropic of Cancer. I never knew what that meant until recently. It means that the sun is in the constellation Cancer at that time of the year.
Oh,
You can think about that and look it up,
Okay.
and we will talk about that later some other time. On that day, the spring equinox in March, anybody living along the Tropic of Cancer, 23.5 degrees north, the sun at noon is going to be as high as it's ever going to get, straight overhead, which is why we who live north of that where do the shadows always point? Come on, you're going to get lost in the woods. How are you going to find your way home if you don't know which way the shadows go?
To the north,
To the north. Who said that?
Regina.
Regina, yes. And we won't talk about the southern hemisphere, but everything is opposite down there. Okay. So we will never, living here in New York, ever see the sun straight over our head. If you wake up someday after a binge and you're lying there on the beach and the sun's straight overhead, you're going to say, I'm not in Kansas anymore. Okay. So 2 lines, Tropic of Cancer in the north, 23.5 degrees north, and the Tropic of Capricorn in the south, 23.5 degrees south. Now there's another 2 lines. We're going to forget the southern hemisphere. If we keep moving north, we're finally going to reach what is called the Arctic Circle, which is at 66.5 degrees north. So we're 2/3 of the way towards the pole. And the reason the Arctic Circle is a line that the sun makes, let me think, on June 20th, the summer solstice, anybody living on that line, the sun never sets for that one day. Now, the further north you go towards the pole, the sun has been up in the sky longer and longer. But that Arctic Circle line is the magical point where only one day do they see the sun circle the horizon like a hula hoop. Now, can you find a picture of the midnight sun on there while we move on? All righty, let me see what I got here. So, I also discovered today, I remember years ago in college, my roommate was from Turkey, and often she asked me what a word meant. And I realized that I suppose any language you do this, there are some words we use in a vague sort of way. And then when you're trying to translate exactitude, it's like, oh, is that really what it means? And one of those words is zenith, which we talked about weeks ago. And I was thinking wrongly, so maybe I shouldn't tell you this because then you'll get the wrong idea. Zenith does not mean 90 degrees overhead. The zenith is simply the highest point in the sky at noon. So if you lived on the equator, and if it was the equinox, oh, nice pictures.
Like this one?
Then yes, at noon, meaning the halfway point, noon is halfway between sunrise and sunset, then yes, the sun would be straight overhead. And then if you lived between the tropics, twice a year when the sun's going north and then south, it would be overhead. But for us above the tropics, above 23.5 degrees, it's never straight overhead, but it does reach the zenith. The arc is just lower for us towards the south. And whenever it gets halfway between sunrise and sunset, that's the zenith. So I thought, okay, Mary Lou, sharpen up your vocabulary because they're not synonymous. Have I confused everybody? Isn't this gorgeous?
Norway.
That's in Norway, okay. And what we're not seeing is, of course, if you were standing in Norway, you would have to, for 24 hours, you'd have to rotate your neck to watch it go all
the way around.
Now, wait a second, don't go away from that one. But it's not evenly along the horizon, you notice?
Can you make it bigger?
Can you make that particular one bigger?
Yes, maybe not.
Okay, whoops. Oops.
Yeah.
Okay, what happened to that one?
There
we
it
go.
is. Okay.
Alrighty.
Here, do you want me to share this
Yeah.
with them?
Yeah, share that with them. We're having all the fun here, seeing the pictures, and you guys aren't.
Yeah, you're right.
Here it comes. It'll come. This is a view from Norway of part of the sky showing the midnight sun. Now think of a hula hoop.
Oh,
And think of that beach ball again. And think of the North Pole at the top. Well, that hula hoop does not sit evenly above the ball, the earth. So the sun does not move counterclockwise, east to west, around the horizon. It's at a tilt. because our axis is tilted. All right, so it's highest when you're looking south in Norway. You know, it might be, let's say, a handspan. And then as it circles behind your head to the north, it might just be an inch above the horizon or whatever it is. But it's quite an interesting phenomenon. And 2 years ago, we were in Finland, actually on, Sandy, you were there, the equinox, remember in March?
Yeah.
And so for us on that third day we were there, I think up in the north, above the Arctic Circle at 67 degrees north, it didn't matter. Everywhere in the world, it was pretty much 12 hours of daylight and 12 hours of dark. The only thing I noticed that was different was that Orion in the middle of the night, we stayed up in the middle of the night because we were there for the Northern Lights. Orion, instead of being this high in the sky, the belt, was down in the treetops because we were further north. And so all the stars that we normally see looked further towards the southern horizon. Okay. And what time is it getting to be? We're running on, aren't we?
1:38.
Okay. Okay, I'm just going to give you this information and then you can kind of remunerate on it like the cows do with their cud. If New York, where we are, is roughly 41.5 degrees north latitude, meaning halfway between what? The equator and the North Pole. Then in the summertime, June, if you go out at noontime and face south and don't look directly at the sun, squint, 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 the sun is going to be about 72 degrees above the southern horizon, the highest it gets for us. But in the wintertime, it's only going to be 25 degrees. Because in the summertime, where is the moon, the sun straight overhead? The Tropic of Cancer, which is somewhere down in the Caribbean, I think. But in the wintertime, it's down beyond Brazil somewhere. So you can think of it as just further away down around the curve of the earth. So it's lower in our sky. All righty, we gotta quickly move on here because I want to get to, we can skip that. All righty. Melanie has volunteered to be the brave one. And I asked her before we started, why is it hotter in the summer than the winter here in the Northern Hemisphere?
Because we're closer to the sun.
Now, did you all hear that?
No, what did she
Yeah, you
say?
have to speak.
Oh, because we're closer to the sun.
In the summertime?
Mm-hmm.
No.
Good for you, Mary Lou. However, most people would say that as the answer. Well, because they know, since our orbit's not a circle, right? It's an ellipse, which is sort of like an oval. And therefore, and the sun, okay, everybody imagine an oval on your tabletop in front of your computer. An ellipse has 2 focal points. And the sun occupies one of them. Which means, can't you admire, you have to admire, and in the winter, we're going to do a little history about the 5 giants, starting with Copernicus and ending with Newton, and how these men figured this out, because the math is just amazingly, how did they ever do it? But they did. And so if the sun's at one focal point, as we go around the ellipse, obviously we're going to be closer to the sun at one time than the other. And who remembers from whatever, if you ever studied this in high school, how far are we from the sun? How many million miles, roughly?
About 93?
About 93 million miles. And then as the mathematician would say, I'm going to round it off, plus or minus 2 million. So sometime we're 91 million miles, and other times we're 95. Rounded off. That's not exact. Wouldn't you think when we're 92 million miles closer, it'd be hotter?
Mhm.
You'd think that. Ain't true. We are the closest in the wintertime, in January, about the 2nd of January, 3rd of January. And we call it, what's the word? Perihelion. And then in the summertime, we're further out by 4 million miles. So that's not the reason why we have seasons. So we'll cross that off. Well, if that's not the reason, where are the flashlights? I forgot, some people knew this. Did you put that online so people knew about the flashlight? Okay. Lost in translation, the radio signals got caught up in the ionosphere and she didn't get my message. So if you have, they can use their smartphone, right? Or a cell phone. All right, if you have your cell phone handy, yeah, she's gonna turn off the light and everybody can do this. It'll take a minute. Yeah. Let me see, Sandy brought her big flashlight. Oh, that's a weird shape though. That has a funny shape.
Okay.
Okay. Pretend the flashlight is the sun. And anywhere between the two tropics on either side of the equator, most of the time the sun is going to be straight overhead so that all its light and heat shines straight down in a concentrated circle of energy, right? But for us in the north, it's never straight overhead because the earth curves. Since I can't curve the table flat top, I'm going to shift the sun. What happens to that circle of light and energy and heat? Can you see that? Or can you do it on your own? Melanie, what happened to it?
It elongates.
It elongated into an oval,
Yeah.
which meant the same amount of heat and light is now spread out over a greater area, which means it's not as concentrated. The sun is not as hot and the light is not as bright. And okay, we can turn our lights on now. And we all know this from experience. If you go out on a winter day and stand with your face to the sun, you can feel a little warmth. But if you went out today and stood with your face to the sun, it would be very hot and very bright. So the main reason we have a hot summer and a cold winter is because of that tilt of the earth changes the amount, it changes where the sun is in our sky and the amount of heat and light that we're receiving over a given area. So that's one reason. Can anybody think of a second?
I found this when I was looking up one of your questions. And I thought this was interesting.
You see, that's what happens, Mary Lou. Have you ever, when you were a kid, you had to look up a word in the dictionary and then that led you to another word and 10
Yes,
hours
that
later you're
happens
sitting
to me
there?
all the time. Still does. Anyway, it's warmer in the summertime and cooler in the wintertime because there's more land in the northern hemisphere,
Oh.
and that tends to lose heat quickly. And in the southern hemisphere, there's more ocean, and the oceans retain the heat.
That's something we should talk, that's really mostly like geology or weather, meteorology. Why can they grow cherries up along Lake Ontario shoreline and not here in Allegheny County? Part of it is that water has a higher specific gravity, scientifically speaking, which means it takes a while to warm up in the fall, but then it holds that heat through the winter. And in the spring, people living close to a large body of water, the ocean or a big lake, will have a cooler spring as the water in the lake takes a while to warm up. You don't want to go swimming in Lake Ontario in June. You really want to wait till July or August. That's part of it. All right, we'll put that on hold because that's not really an astronomical answer, but it's true. Let's go back to San Diego and New York. for length of day. In the northern hemisphere, the days are longer. So the sun is up longer. So the sun has a chance to heat you up more. So that's probably the second reason.
Oh, okay.
Okay. And the third one I didn't think about and didn't know until I read it in the book where I learned most things. Once again, think of that sphere being surrounded by a thin layer of atmosphere. Think of the sun hitting the earth at the equator, smack on. It only has to go through, how high do those planes fly? 30,000 feet straight through. Whereas if it's coming in more towards the North Pole or Finland, say, it's cutting in at an angle and passing through much more atmosphere. And the atmosphere absorbs light, scatters it, blue skies. It absorbs the heat as well as the light. And so the further north or south you go from the equator, the more the angle of the sun will be. And therefore it will lose some of its heat and light. And you won't have as warm a summer up there. Anybody have questions before we go on? We need to talk about the questions for next time. Any questions before we move on? Deborah, you still there? Oops.
I'm here.
Okay, Jordan, you still there?
Yeah.
Okay. Next time, July 20th, we're basically going to talk about if we can manage at least one. The main constellation we're going to study is Scorpio. And if we have time, we'll look at Hercules and the Corona Borealis. Have time. So here are the questions. Jordan, do you think Brock still wants to answer questions or not?
No, I don't think he can right now.
I can't hear you.
He can't right now.
I still didn't hear you.
He can't answer any for a little while. So
Okay.
probably shouldn't give him any for a little bit.
Okay, well then, Jordan, I'm going to have you answer question 1 and 2, and it's about the constellation Hercules.
Okay.
Alrighty. 1, what is its nickname? The something or other
Okay.
constellation. And then number 2, there is one of those cluster of stars in Hercules that's very famous, M13. I'm not sure it has a nickname. I think people just call it M13. And it's supposed to be the second best cluster in the Northern Hemisphere. So what I want you to figure out is what kind of cluster. We talked about 2 kinds a couple of months ago. And where do we find it in Hercules? So we can, when we do our next stargazing party in about 6 weeks, we'll know where to, Melanie, to point the binoculars. No, the telescope. And what age is it? So M13, where do we find it in Hercules? And how old is it?
Okay.
Okay. Sandy, you want a hard one? Sandy's sitting right here, so she's going to get hard. Regina, I'm going to ask you something too here in a minute. Regina, are you still here?
Yes.
Okay. Not this question. Sandy, since we're running late and you're here, after we get done, I'll tell you what to look up. And she has to look up the alpha star in Hercules. Okay, Regina, ready?
Yes. Yep.
Corona Borealis. Borealis.
Corona, did you say?
Yes, Corona Borealis.
Uh-huh.
3 little questions. 2 questions. What is its nickname?
Okay.
And what is the alpha star? Now, you weren't here earlier, and I don't know how much astronomy you know. When you have a constellation, usually the brightest star is called the alpha star, the Greek alphabet, alpha, beta.
Uh-huh. Yes.
Yeah. So find the brightest alpha star in the Corona Borealis, and then what is its more common nickname?
Okay.
And I have one for Bob because he's been to Australia, but I'll phone him that one.
How about me?
Mary Lou, you ready?
Yes,
What is the alpha star in Scorpio? What is its name? And then what color is it? All right. Deb, you there?
I'm here.
Okay. I finally, in one of my 7 books, I think I've come up with the correct answer, and you can research it and see if that one book is right. In Scorpio is another globular cluster called M4. Its nickname is the cat's eye. What I want to know is, why does it have that name? Cat's eye. Cats being possessive. All right.
So you want to know why they call the globular cluster M4 cat's eye?
Yes.
Okay.
M4. All righty. Who has not gotten something? She hasn't. All righty.
Me, Mary Lou, Rima.
And Rima. Well, okay, Rima. I have another one for you at the end here. No, that's Laura's. Okay, Melanie, I'll give you this one. Okay, Rima. There are going to be 2 open clusters in Scorpio. The first one is M7. What is its name? And I already gave you the answer. It's an open cluster. And where do we find it in relationship to Scorpio? And then Melanie, M8, which is nearby, what is its name? And where would we find it in relationship to Scorpio? And then Laura, I guess, is traveling, and she left this morning, so she didn't tune in, but I'm going to call her. She has to do, one of these stars we're going to be looking at is a red giant. And so I want her to research the history of red giants. What happens to them? All righty. And then I also circled up here at the top for Melanie, when we get together in 6 weeks or so and look at the southern stars, such as Scorpio, Sandy, were you the one that was going to look up who was looking up the alpha star in Hercules? Was that? Okay. Yeah.
but you didn't tell me more than that.
Okay, I will later. That particular star is it's the alpha star in Hercules, and it's one of those beautiful double stars that's orange and blue-green, and you can see it easily with a telescope. So when we get together in a couple of weeks on my hill, and Melanie has a telescope, we're actually going to be able to see it. If the sky is clear. Well, we only do it on a clear night. So does anybody have any questions? We ran kind of late this time. It's what time is it? Almost 2?
Yes.
Yeah.
5 minutes.
So quick questions, and then we're going to have to close it down.
I have a comment
Yeah.
that part of my assignment was about Stonehenge and the solar solstice.
Yes.
And people are still, just a comment, people are still going to Stonehenge
Yep.
and celebrating the summer solstice. I was surprised about that.
Yes. But one of the things, and you know what, Regina, I'm sorry about that. I didn't have it written down, or we were running out of time, and I had forgotten I'd asked you to do that. We will talk about Stonehenge. We'll slip it in somehow next time. But I want to point out that Stonehenge, they started building it about 5,000 years ago, the same time they started building the pyramids. And it was built over a 1,500-year time span by 2 separate cultures that had nothing to do with the Druids. They didn't show up until 500 BC. So
yeah, I read that too.
yeah. And so that's a real misconception, non-truth that keeps bubbling up and going on, but it's not true.
Well, I don't know. Do you know about Dr. Lynn Kelly, who wrote a book called The Memory Code?
Nope.
I think anybody might be interested in this. And it was a book I got to do my little research. but she's saying that's written so all those pillars and things are significant for memorization of history and stuff. It's very interesting. And
Yes.
she says a lot of ancient monuments are for people to memorize things and
Okay.
to, recite and all that kind of thing.
What is really, really interesting when you start studying ancient monuments, especially since there was no written record, it's really hard sometimes for us moderns to figure out what was going on back then. And sometimes it's like reading a poem or the tea leaves or whatever, or Rorschach tests, right? And the more ancient it is, the more vague it is, the more people with all sorts of ideas, some weird and some based on science, can come into the arena and present their ideas. So the only defense against weeding out the erroneous, or let's go to the extreme, the nuts ideas, is the more that you learn from, I don't want to say certified, but knowledgeable people who have studied the area their whole life and have a lot of experience. And so Stonehenge is certainly in that category. They're just like the pyramids. I could go on for a whole hour on the pyramids, but I won't.
Thank you.
Thank me. Okay. Sandy's got to go to Albany. She's waiting to hop in her car and leave here. But so it's hard for the person without a lot of expertise to weed out what's true and what's not. So you have to read these books with a grain of salt. Is that the word? I don't know where that phrase comes from, but they certainly, some of the theories are very fascinating. And we'll talk about, everybody should look up Stonehenge as a homework assignment for next time, as well as your one question, because Stonehenge, for the people here in the West, is an amazing monument. And sometime, once again, in the late fall or early spring, when there are less interesting stars to look at, I bought a new book called The Celestial Geometry, which is amazing because Stonehenge is only one of thousands of stone ancient monuments that were erected for keeping track of the sun, the moon, the stars in different cultures all around the world. And some of them are very amazing. So we'll
Yeah.
look at those. Anything else? Okay, guys, 2 weeks and we'll
Thank you.
be looking at mainly if at 10, 11 o'clock at night right now, Scorpio is pretty much to the south, right up in the middle of the sky. Okay, thanks.
Thanks, Mary Lou.
Bye.
Bye-bye. Thanks for tuning